Good evening, children.
Yeah.
Good evening. Good evening, children. All right, I think we stopped with this one in the last class. So I was telling you that in this figure, we have two isosceles triangles on the same base BC. We have two isosceles triangles. See here, triangle ABC is an isosceles triangle. And triangle DBC is also an isosceles triangle. BC is the common base for both the isosceles triangles. For both the isosceles triangles, BC is the common base. So above BC, there is one triangle ABC, which is isosceles with AB equal to AC. Below BC, there is another triangle, which is also isosceles with BD equal to DC. Now, such a figure is a kite. There's actually a kite. A kite is a quadrilateral in which both the pairs of adjacent sides are equal. So see, when this side is equal to this side and this side is equal to this side, it's a kite. If you look at this as a quadrilateral, if you look at this as a quadrilateral ABDC, if you look at the whole figure as a quadrilateral ABDC, then it is a kite. Because a kite is a quadrilateral in which each pair of adjacent sides is equal. So see here, adjacent sides AB and AC are equal. And adjacent sides BD and DC are equal. Okay, but here the figure is not described as a kite. It's described as two isosceles triangles on the same base BC, one above BC, the other below BC. Well, we have to prove that this angle is equal to this angle. That's a property of a kite. In a kite, one pair of opposite angles is equal. In a kite, one pair. In a parallelogram, both the pairs of opposite angles are equal. In a kite, one pair of opposite angles is equal. So that's what we are actually proving, the property of a kite. Or we have to prove that this angle is equal to this angle. So we are proving, if you look at ABDC as a quadrilateral, you're proving the property of a kite. So we learned it in two ways. One is when two sides are equal, the angles opposite them are equal. So since this side is equal to this side, angle 2 is equal to angle 1, or angle 1 is equal to angle 2 in this triangle. Similarly, angle 3 is equal to angle 4 in this triangle. And when you add the two results, angle 2 is equal to 1, 4 is equal to 3. When you add the two results, so angle 1 plus 3 is equal to 2 plus 4. 1 plus 3 is equal to 2 plus 4. And 1 plus 3 is 1 plus 3. 1 plus 3 is angle ABD. And 2 plus 4 is angle ACD. 2 plus 4 is angle ACD. So like that, we get this result, or we prove the result that angle ABD is equal to ACD. The other method is by just removing this common base BC and taking up the diagonal AD. See, this common base BC is also one of the diagonals of the kite. The common base B, if you look at the figure as a kite, BC is one of the diagonals of the kite. One of the diagonals of the kite. So take away the diagonal BC. Take away the diagonal BC and join the diagonal AD. Take away the diagonal BC and join the diagonal AD. So you can understand like this. With respect to the diagonal BC, this is how we prove. This is how we prove. With respect to the diagonal AD, this is the proof. If you take the diagonal BC, this is how we prove it. If you take the diagonal AD, this is the proof. Okay, what is the proof? Simply show that these two triangles are congruent to each other. Once they are congruent, their corresponding angles or their corresponding parts are equal. So it's very easy to show that these two triangles are congruent. This side is equal to this side given. This side is equal to this side given. Okay, let me say like this. This side of the first triangle is equal to this side of the second triangle. This side of the first triangle is equal to this side of the second triangle. And AD is a side common to both the triangles. So by SSS congruence rule, the two triangles are congruent. CPCTC, we have this angle ABD equal to angle ACD. So till here we finished in the last class. Right, children?
Yes, ma'am.
Yes, children. Okay. So now let's continue. So triangle ABC is an isosceles triangle. Triangle ABC is an isosceles triangle. So ABC is an isosceles triangle with AB equal to AC. Side BA. So when they say BA, you should produce it like this. Side AB means downward. See, like if you call the triangle ABC like this, if they say the side AB is produced, AB produced means in this direction. In this direction. If they say BA produced, ABC triangle. If they say BA produced like this. So here, the way you name the side is important. When you're producing the side, AB is different from BA. When you're producing the side, otherwise AB, BA both are the same. Simply to refer to the side, AB, BA refers to the same side. But when you're producing, you will be producing it in one particular direction. So when you say AB produced, it will go like this. AB produced is like this. AB produced like this. If it's BA produced, it will be like this. So isosceles triangle ABC with AB equal to AC. Then side BA. So this is B, this is A. BA produced. BA is produced to a point D. It's produced to a point D, such that AD is equal to AB. So whatever is this length AB, supposing this is 4 centimeters, then it's produced to D such that AD is also 4 centimeters. If AB is 4 centimeters, this BA is produced to D such that AD is also 4 centimeters. That's why they're saying such that AD is equal to AB. AD is equal to AB. So if AB is 4 centimeters, AD is also 4 centimeters. Show that angle BCD, but we can't see the angle BCD at all. See, where is angle BCD? So you have to join something. To make out the angle BCD, you have to join. So you have to join DC. You have to join DC. Now you can see angle BCD, this one. This is angle BCD. This is angle BCD. Okay, we need to prove that angle BCD is a right angle. Is a right angle. So sometimes they'll not give you the figure. They'll not give you the figure. That's why I'm explaining. Okay, so they'll only give you the description of the figure, and you have to understand the description and make the figure and then prove. So triangle ABC, it's an isosceles triangle with AB equal to AC. Side BA, so this is BA is produced to a point D, This is D, this one is D, okay, to a point D such that AD is equal to AB. This AD is equal to AB. So that means now AD, AB, AC all have the same length. AD, AB and AC, all of them have the same length. Now with this, you'll have to show that BCD is a right angle, but you cannot see the angle BCD at all here. For that, you'll have to join, DC. Now here is angle BCD. You'll have to prove that angle BCD is a right angle. So this is the information, and that's what you'll have to prove. BCD is equal to 90 degrees. Okay. Okay. So I have marked off some angles here. See here. See now, when you start off, you will not know that you will have to mark now. As soon as you, start working the proof, you will not know that you have to mark 1 here, 2 here, and all that. So you have to see now. Just assume that I have not marked anything. I have not marked anything. How do I know that I have to mark 1, 2, 3, 4 here? Even I don't know. So only when you start working, when you want to mention some angles, then you go and mark them as 1, 2, and then you need 1 more angle, so 3, and then 1 more angle, 4. So as soon as you start the proof, you cannot draw the diagram and mark angles 1, 2, 3, 4. That nobody can do. So we start working, and then we need to say that this angle is equal to this angle. At that point, you go to that angle or those angles and mark 1 and 2. So to start off, you'll only draw the figure. You cannot mark any angle. Okay, now So triangle ABC is an isosceles triangle because you know AB is equal to AC. AB is equal to AC. So the angle opposite to AB is this angle, and the angle opposite to AC is this angle. So you want to say that these two angles are equal. So you mark this as 1 and 2. You can mark this as 1 and this as 2 also. So there is nothing like, you know, this is 1. So since I need to, say that this angle is equal to this angle, I mark 1 and 2 here. So angle 1 is equal to angle 2. So I haven't still marked 3 and 4. I haven't still marked 3 and 4. So we start off like this in triangle ABC. AB is equal to AC. So we know that angles opposite to equal sides are equal. Opposite to AB is angle. See, you should see only the triangle. You must see only that triangle ABC. ABC. You must see only the triangle ABC. Opposite to AB is this angle, and opposite to AC is this angle. So I've marked this one and this one too. Angle 1 is equal to angle 2 because angles opposite to equal sides are equal. Now, since AD is equal to AB, see here AD is equal to AB. That means, and we have two results. See, write it like this. AD is equal to AB and AB is equal to AC. See here, these two results. These two results. AD is equal to AB and AB is equal to AC. So that means you get a new result. AD is equal to AC. AD is equal to AC. Comparing these two, you get a new result. See what you compare. You compare what is given. AB is equal to AC and AD is equal to AB. You compare these two, what is given. So you have AB common there. So that means AD is equal to AC. AD is equal to AC. Please understand. We are given that AB is equal to AC and AD is equal to AB. That's what I've written here. Now, when you compare these two, AB is common. AB is common. So that means AD is equal to AC. AD is equal to AC. And now AD and AC are sides of which triangle? AD and AC are sides of triangle ACD. AD and AC are sides of triangle ACD. So AD is equal to AC in triangle ACD. In triangle ACD. That's a new result we've got. Now again, let's use the isosceles triangle property. In a triangle, when two sides are equal, the angles opposite to them are also equal. So in this triangle ACD, this side is equal to this side. So opposite to this, in this triangle, you must see within this triangle, opposite to this side is this angle. Opposite to this side is this angle. So you want to say that this angle is equal to this angle. So now we mark 3 and 4. Now we mark. So like this, we mark the angles. When you need, you go there and mark. So now in triangle ACD, since this side is equal to this side, angle 3 is equal to angle 4. Because again, angles opposite to equal sides are equal. So now we have these results. Angle 1 is equal to angle 2. Angle 3 is equal to angle 4. Angle 1 is equal to angle 2. Angle 3 is equal to angle 4. These are the results we have. Now let's use the angle sum property in triangle. The whole triangle. That is the whole triangle is triangle BCD. Why in the whole triangle BCD is because you have to find this angle, which is an angle of the triangle, which is an angle of the whole triangle BCD. You'll have to prove that angle BCD is 90 degrees. You'll have to prove that angle BCD is 90 degrees. And BCD is in this big triangle, in triangle BCD. So take up the whole triangle BCD and use angle sum property. Okay, so this angle, this is one angle, angle 2. This is one angle. It looks like 2 here, but there's only one angle of the triangle. 1 plus 3 is one angle. 1 plus 3 plus 4 plus 4. These are the three angles of the big triangle BCD. So this is one angle, 1 plus 3. This is one angle, 2. And this is the third angle, 4. Is equal to 180. See, we are not adding 4 angles. There are only 3 angles of the triangle. So the sum of these 3, and that's why I put a bracket here. These two make only one angle, BCD, is equal to 180. Is equal to 180. But now we need to prove that BCD is 90 degrees. So you want only angle 1 and angle 3. You don't want 2, you don't want 4. You want only 1 and 3. Because 1 plus 3 is only BCD. What is BCD? Angle BCD is equal to 1 plus 3. 1 plus 3 is BCD. So you don't want 2 and 4. You don't want 2, you don't want 4. So what you do, you write 1 and 3 as it is. Now instead of 2, see 2 is equal to 1. So instead of 2, you can use 1. And 3 is equal to 4. You want 1 and 3. You don't want 2 and 4. See here. You don't want 2, you don't want 4. So what is 2? 2 is equal to 1. So 2 is replaced with 1. And 4 is equal to 3. So 4 is replaced with 3. So next step, you can angle 1 plus angle 3 plus angle 1 plus angle 3 is equal to 180. I've written using A and B because see here, I've called this A and B, the results A and B. So this A and B also you cannot write like when you write angle 1 is equal to 2, here itself you cannot write A. You cannot write that. How will you know that? You'll have to mark that as A. So when you come to this point, when you come here, so you will write angle 1 plus angle 3. Now we are going to replace angle 2 with angle 1. So then you'll mark this one as A because you're using that result here. Then plus angle 4, you're going to say angle 3. So then you will mark this result as B. And here you will say using A and B. Like that we write using A and B. So as soon as you wrote angle 1 is equal to 2, you cannot write A here. We don't know. How do we know? So now at this point, when you write 1 plus 3 plus, you're replacing 2 with 1 and 4 with 3. At this point, you go here, you mark it as A and B, and then here you say using A and B. So twice of angle 1 plus twice of angle 3 is 180. 2 common. Angle 1 plus angle 3 is equal to 180. Then 2 goes for division. 180 by 2, 90. So angle 1 plus angle 3 is 90. What is 1 plus 3? BCD. So BCD is 90. Got it, children?
Yes.
All right, children. Any questions, children? Please ask me. Okay, I'll give you 1 minute to go through the answer. Go through the answer. I'm right here. You can ask me if you want. If you have any doubts, you can ask me. Done, children?
Yes, ma'am.
Okay. It's very simple. So it's given that ABC is a right angle triangle. So in which angle A is 90 degrees. So see here, ABC is a right triangle in which angle A is 90. A is 90. So BC. And AB is equal to AC. So this is a right isosceles triangle because it's a right triangle and also an isosceles triangle because two sides are equal. It's called a right isosceles triangle. It's a right isosceles triangle because it's a right triangle as well as an isosceles triangle. So if these two sides are equal, we know that the angles opposite to these two sides will also be equal. So I've told you one thing. AB is the side, so C will be the angle. AC is the side, so B will be the angle. That letter which is not included. See, there are only 3 vertices, no? The side will take 2 vertices. Side AB, opposite is angle C. AB, so C is the opposite angle. Side AC, so B is the opposite angle. ABC. For the side AB, C will be the opposite angle. ABC. For the side AC, B will be the opposite angle. So opposite to AB is angle C. Opposite to AC is angle B. So these 2 angles will be equal. These 2 angles are equal. So now what? 180 minus 90. 180 minus 90 is 90. So these 2 angles are equal. So it will be 45, 45. It will be 45, 45. So that's what is the question. Find angle B and angle C. That's the question. Find angle B and angle C. Yeah, I think it's simple, children. You can go through. Fine, children.
Yes, ma'am.
Yeah. So here also see, we need to show that all the angles of an equilateral triangle measure 60 degrees. So we know that every angle of an equilateral triangle measures 60 degrees. We have to show that, or we'll have to prove that. So again, we use that isosceles triangle property, ABC. In an equilateral triangle, we know that all the 3 sides are equal. Okay, now let's take it one by one. AB is equal to BC. AB is equal to BC. So which is the letter missing, children? AB is equal to BC. So opposite to AB is which angle? Angle? Opposite to AB is which angle?
Angle C.
C is equal to opposite to BC is which angle?
A.
A. So this is one result. Yeah. Now take 2 other sides. Take BC is equal to AC. BC. See, AB is equal to BC is equal to AC. All the 3 sides are equal because we are not proving it's an equilateral triangle. We are given an equilateral triangle. The triangle is equilateral. All the three sides are equal. Or we have to show that each angle is 60 degrees. So we know that AB is equal to BC. All the three sides are equal. We are taking two at a time. AB is equal to BC. So we know that when two sides are equal, the angles opposite to them are also equal. So we have C is equal to A. Now take two other sides. BC is equal to AC. Now which is the angle opposite to BC?
Angle A.
Angle A. And opposite to AC?
Angle B.
Angle B. We'll call this result 2. Yeah. Now can you see? C is equal to A and A is equal to B. That means A, B, C all are equal. Because see, angle C is equal to angle A. These two are equal. So that is if angle A is 60 degrees, then C is also 60 degrees. Just for example. Now A is also equal to B. A is also equal to B. How much is A? 60. Then how much will be B? B also will be 60. That means see here A, B, C all are 60. No, if I use 60, then maybe you will have a doubt. I'll not say 60. I'll just say X. 1 minute. Now angle C is equal to angle A. Okay, so supposing angle C is X degrees, then A is also X degrees. Now we have angle A is equal to angle B. Angle A is X degrees. So here also angle A is X degrees. And because it's equal to B, B is also X degrees. Now see here, A is X degrees, B is X degrees, C is also X degrees. So from 1 and 2, angle A is equal to angle B is equal to angle C. So have this result. Now use the angle sum property in a triangle. Angle A plus angle B plus angle C is equal to 180. Okay. Now we know all the three angles are equal. So write A as A. Now B is also A because A, B, C all are equal. So you write B as A plus angle C also as angle A is equal to 180. So thrice you can replace anything. Like you can make everything angle B also. You can write A is B, B is B, C is also B. Anything. You can get thrice of angle B, thrice of angle C, thrice of angle A. Anything you can write is equal to 180. So angle B is equal to 180 by 3, 60 degrees. 180 by 3, 60 degrees. So if angle B is 60 degrees, since A, B and C are equal, A is 60, B is 60, C is also 60 degrees. Now you can compare with, you should write any two results. See, we know that AB is equal to BC. So you all said opposite to AB is C, BC is A. This is one result. You can also write this one, AB is equal to AC. See, we can write three things. AB is equal to BC. We can write AB is equal to BC. BC is equal to AC. AB is equal to AC. You write any two of these three. We can write three things. When all the three sides are equal, AB is equal to BC, BC is equal to AC, AB is equal to AC. You write any two. That's enough. Any two. So opposite to AB is angle C. Opposite to AC is angle B. This is 2. Now when you compare these two, C is equal to A, C is equal to B. So all are equal. A is equal to B is equal to C. Because here also you have C equal to A and C is equal to B also. That means A, B, C all are equal. Understood, children?
Yes, ma'am.
Yeah, that's what you see here. Exactly what I explained here, you can go through. All right, children?
Yes, ma'am.
All right. So with this, we come to the end of exercise 7.2. Yeah. So here, AB is a line segment. AB is a line segment. You can see, sorry, 1 second. Yeah. AB is a line segment. P and Q are points on opposite sides of AB. 1 second, children. Sorry, children. Yeah. So AB is a line segment. You can see here AB is a line segment. P and Q are points on opposite sides of AB. So here P and Q are points on opposite sides of AB such that each of them is equidistant from the points A and B. So let's draw it by ourselves. Here AB is a line segment. AB is a line segment. P and Q are points on opposite sides of AB such that each of them, that is P, each of them meaning each of P and Q is equidistant from A and B. That means P is equidistant from A, P is equidistant from B. That means PA is equal to PB. P is equidistant from A and B. That means PA is equal to PB. Q is equidistant from A and B. That is, if you walk from Q to A and walk from Q to B, the distance is the same. The distance is the same. The distance QA is equal to the distance QB. That means Q is equidistant from A and B. When you walk from Q to A and from Q to B, the distance QA is equal to the distance QB. That means Q is equidistant from A and B. Again, this is a kite. Again, this is a kite. See here, adjacent sides are equal. Again, this one is a kite. If you look at this as a quadrilateral, PAQB. If you look at this as a quadrilateral PAQB, it's a kite. Because a kite is a quadrilateral in which both the pairs of adjacent sides are equal. Not like this. See, you should understand that. Now, when we say adjacent side, not this side and this side, how can they be equal? So this side is equal to this side and this side is equal to this side. The two longer sides are equal, the two shorter sides are equal. Okay, so this is the figure. Now we need to show that the line PQ, that is the diagonal of the, see, if you look at it as a kite, it's the other diagonal, the diagonal PQ. Okay, show that the line PQ, that is the diagonal PQ, is the perpendicular bisector of AB. So you need to prove that the diagonal PQ bisects, that is one diagonal is the perpendicular bisector of the other diagonal. So we know that in a parallelogram, diagonals bisect each other. In a parallelogram, diagonals bisect one another, but in a kite, the diagonals don't bisect each other. The longer diagonal bisects the shorter diagonal. The diagonals are perpendicular to each other, but when it comes to bisecting, the diagonals are perpendicular to each other, but the diagonals don't bisect each other. The longer diagonal bisects the smaller diagonal. So that's what we're going to prove here. Show that the line PQ, so what is PQ? PQ is the other diagonal, the longer diagonal of the kite PAQB. So you need to show that the longer diagonal PQ is the perpendicular bisector of the smaller diagonal AB. So which means we understand two properties here. In a kite, the diagonals are perpendicular to each other. We understand two properties of a kite. In a kite, the diagonals are perpendicular to each other. And in a kite, the longer diagonal bisects the smaller diagonal. The smaller diagonal is cut into two equal pieces. The longer diagonal is not cut into two equal pieces. The longer diagonal is not cut into two equal pieces. The longer diagonal cuts the smaller diagonal into two equal pieces. So the longer diagonal bisects the smaller diagonal. And the diagonals are perpendicular to each other. So like this, so from the one question earlier, we learned the property of the kite, that one pair of opposite angles are equal. Okay, we learned the proof in two ways. So we proved the property of a kite there. In a kite, one pair of opposite angles are equal. In a parallelogram, both the pairs of opposite angles are equal. In a kite, only one pair of opposite angles are equal. In a parallelogram, diagonals bisect each other. One diagonal bisects the other diagonal bisects the first diagonal. But in a kite, the longer diagonal bisects the smaller diagonal. So when you compare a kite and a parallelogram, in a kite, one pair of opposite angles are equal. In a parallelogram, both the pairs of opposite angles are equal. In a kite, diagonals are perpendicular to each other. But in a parallelogram, diagonals are not perpendicular to each other. In a parallelogram, in a rhombus and in a square, the diagonals are perpendicular to each other, but not in a parallelogram in general. In a kite, the one diagonal, that is a longer diagonal, bisects the smaller diagonal. In a parallelogram, the diagonals bisect each other. So we'll see all these properties in the next chapter, quadrilaterals. So that's what it is here, children. So now we have to prove that the longer diagonal PQ is the perpendicular bisector of the smaller diagonal AB. So you need to prove that the diagonals are perpendicular to each other. The diagonals are perpendicular to each other, and the longer diagonal bisects the smaller diagonal. That's all it is. So you're proving the properties of a kite here. Very, very simple proof. See here. So you know that this side is equal to this side. This side is equal to this side. Okay, now you have to show that bisector, meaning you'll have to show that AC is equal to BC. See, you want to show the smaller diagonal is AB. AB is cut into two equal pieces. That means you should show that AC is equal to BC. See here, PQ bisects AB. PQ bisects AB. PQ bisects AB means cuts AB into two equal pieces. So you should show that AC is equal to BC. This is one thing. And PQ is perpendicular to AB. PQ is perpendicular to AB. So that means this is PQ, this is AB, 90 degrees. So these are the two things we'll have to prove. PQ perpendicular to AB. So PQ, AB perpendicular. You'll have to prove that. Next, PQ bisects AB. Bisects AB. AB is bisected. So that means you should prove that AC is equal to BC. So these are the two things. That's all you'll have to prove. So to prove these results, you can take up, listen to me till the end, okay? So you'll have to take up these. See, normally what do we understand? Wherever we have to show that AC is equal to BC. So AC is of this triangle. BC is of this triangle. And then you'll have to prove this is 90. So clearly you can take up these two triangles and show that they are congruent to each other. And CP, CTC, you will get AC is equal to BC. Or you can take up Or you can take up these two triangles, because AC is in this triangle, BC is in this triangle. So you can show that these two triangles are congruent to each other. So CP, AC is equal to BC, and then you can prove 90 degrees. You can see this is 90, this is 90, all the same. Everywhere it will be, if one angle is 90 here, everywhere it's going to be 90. Everywhere it's going to be 90. So you can take up these two triangles and prove that they are congruent to each other and get the results, or take these two triangles. Class, use the emoji, raise your hand. Madhumita, Netra, Rishmika, Shri, Raja, Sindhu, Sanjay, and Srijana. Very good. All right. So, yeah, I was telling you that to show that AC is equal to BC, you can prove that these two triangles are congruent or these two triangles are congruent. So let's start. That's all. So we'll try to prove that these two triangles are congruent to each other. Or you can take these two children, anyone, any pair you can take. Let me take this pair. Yeah. Now tell me, what are the information available, children? We'll write out whatever is available. Tell me. In triangle PAC and triangle PBC, what are the things you have?
Ma'am, P is equal to PB, ma'am.
Yeah, PA of this triangle is equal to PB of this triangle. Correct, it's given. Then
PC is common, ma'am.
PC is the common side. Very good. PC is equal to PC. Then you have one more information. Let me see who can find that.
Ma'am, angle PAC is equal to angle PBC, ma'am.
Yeah, angle PAC is equal to angle PBC. Very good. Because what's the reason, Sanjay?
Ma'am, angles opposite to equal sides are equal, ma'am.
Very good. So when you look at this triangle alone, look at this triangle alone. Look at the triangle PAB. PAB. Okay, so PA is equal to PB. PA is equal to PB is given. So opposite to PA is this angle. Opposite to PB is this angle. So this angle is equal to this angle. See, don't see this line in the middle. This property is to be used in one triangle without any line segments in the middle. Without any line segments in the middle. So don't see this line segment. Don't see this line segment. It's not there. So these two sides are equal. Opposite this side is this angle. Opposite of this side is this angle. Should see only that triangle. Where do you have the sides PA and PB? In triangle PAB. So see only in that triangle. Don't see this line segment which comes in the middle. So these two angles are equal. Correct. So as Sanjay said, angle, let me number it as 1 and 2. 1 is equal to 2. So Sanjay, angle 1 is equal to angle 2. Yeah. Now what rule does it make, children? What rule does it make?
Angles opposite to equal sides are equal.
No. What congruence rule it makes now? We have mentioned that this is the common side. This is the common side. This side is equal to this side, and this angle is equal to this angle. So what do we have any other information, children? Do we have any other information? Children, in triangle PAC and in triangle PBC, do we have any other information apart from what we have written here? Yes, children. Do we have any other information apart from what is written here on the screen? Yes or no?
No.
One second, children, 1 second. Raju. Actually, yeah. Do we have any other information apart from what is written? Yeah, tell me, children.
No, ma'am.
No. So using, yeah. So what rule does this make? We have two pairs of equal sides. So SS. Is it SAS?
Yes, ma'am. No, ma'am.
No, ma'am. The angle is not included angle.
Yeah. It's not the included angle, correct?
Yes, ma'am.
Yes, ma'am.
So using this information, can we say that the triangles are congruent?
No, ma'am.
Yes, ma'am.
No, because it does not satisfy any congruence rule. This is SSA, not because now don't think, okay, then you write this one here and this one here, then it will become SAS. Not like that. It's not from the order in which we write. It's from the figure. It's from the figure. It's not from the order we write. It's not that, okay, fine, now it's not SAS. You just put this angle information 2 and, bring this one down, then it will become SAS. Not like that. Look at the figure. So for angle 1 and angle 2, which are the arms? I've been telling this. For angle 1, which are the arms? AC and AP. And for angle 2, BC and BP. We have mentioned about AP, but not about BP. Oh, sorry, we have mentioned about sorry, so clumsy. This is angle 1. These are the arms of the angle. But we haven't mentioned about AC here. See here, it's about PA and PC. And for angle 2, which are the arms? BC and this one, PB. PB is there, but BC is not here. BC is not here. We have PC. Somebody's mic is enabled. Please disable your mic. So it is not SAS, children. That means we do not have, the triangles are congruent, but we do not have sufficient information to show that the triangles are congruent. The triangles are congruent, but we have limited information. We have only these three equalities. Using these three equalities, we are not able to show that they are congruent. Does it mean that they are not congruent? With the information available with us, we are not able to show that they are congruent to each other. So we need to get one information that will help us to use a congruence rule and show that they are congruent. For that sake, what we do, we have to take up some other two triangles and get a new information. We'll have to take up some other two triangles and get a new information. So see here. One minute, children. Yeah. So for that, what we do, we take off this line from the middle. You know, we take off this line from the middle and we use the figure like this. Now we show that these two triangles are congruent to each other. We show that, see, this one, this is a different question. Now don't get confused. This is a different one. But when you take off this line from the middle, it will look like this. Take off this one. Take off this diagonal AB. So it will look like this. It will look like this. So now in these two triangles, this side is equal to this side is equal to this side, and this is the common side. So by SSS congruence rule, these two triangles are congruent to each other. So CPCTC, this angle is equal to this angle. Or if you're taking these two triangles, then you must say that this angle is equal to this angle CPCTC. See here, this side is equal to this side is equal to this side, and this is the common side. AD is the common side. So these two triangles are congruent by SSS congruence rule. CPCT, you can say angle 1 is equal to angle 2, or you can say this angle 3 is equal to angle 4, depending on which triangle you're using. If you're using these two triangles, say this angle is equal to this angle. If you're using these two triangles, say this angle is equal to this angle. Now we have got that information. So we did not have sufficient information. So we took up some of the two triangles. We got a new additional information. Angle 1 is equal to angle 2. Now PA is equal to PB. PC is equal to PC common side. Angle 1 is equal to angle 2 included angle. So the two triangles, these two triangles are congruent by SAS congruent rule. CPCTC, AC is equal to BC. AC of this triangle is equal to BC of this triangle. So since we didn't have sufficient information, we proved that those two triangles are congruent. Get this new result, angle 1 is equal to angle 2. Now we take these two triangles. This side is equal to this side. This is the common side. And included angle 1 is equal to included angle 2. So SAS rule, the two triangles are congruent. These two triangles are congruent. CPCTC, AC is equal to BC. And also this angle is equal to this angle. CPCT, this angle is equal to this angle. This side is equal to this side, and this angle is equal to this angle. Those two angles are equal. Supposing you call them 3 and 4, angle 3 is equal to angle 4. But what is angle 3 plus 4? Is a straight line. So 3 plus 4 is 180. 3 is equal to 4 CPCT. But 3 plus 4 is 180 because they're on a straight line. But 3 and 4 are equal. So 3 plus 3 is equal to 180. 3 plus 3 is 180. So that means twice of angle 3 is equal to 180. Angle 3 is equal to 90 degrees. So we proved that the diagonals are perpendicular to each other. When you look at it as a kite, the diagonals are perpendicular to each other because this is 90. Or we have proved that PQ is perpendicular to AB. So because we proved AC is equal to BC, PQ bisects AB. And we proved that this angle is 90. That means this is also 90. So we proved that this is 90. That means PQ is perpendicular to AB. So we have to prove two things. PQ is perpendicular to AB. So 90 degrees. PQ is perpendicular to AB. Then we'll have to show that PQ bisects AB. So we proved that AC is equal to BC. So PQ bisects AB. So from these two results, PQ is the perpendicular bisector of AB. Go through the answer, children. Haven't shared this answer slide, right, children?
Yes, ma'am.
Yes, ma'am.
Yeah, please write down then. Please write down, children. I'll just come back in 5 minutes. Please write. Done writing, children? Children finish writing?
Yes, ma'am.
Yes, ma'am.
Okay. Okay. Now who can tell me the proof? Okay, I'll ask. Yeah, Raja. Show that these two triangles are congruent to each other. List out the information you have to show that these two triangles are congruent to each other. Raja? Yes, Raja. Can you hear me? Raja, are you there?
Ma'am, sorry, ma'am. I went to restroom. Sorry. Screen is on.
Okay, Raja. I was calling out to you for a long time. Okay.
Sorry, ma'am.
Yeah, I'll come again with my question. You finished writing the proof, Raja?
No, ma'am. Just
Okay, take a screenshot, write it later.
sorry, ma'am.
Yeah, take a screenshot, write it later.
Yes, ma'am.
Yeah. Yeah, now tell me the information available to show that these two triangles are congruent. Yeah, quickly. Fast, fast. Yeah.
AP is equal to BP.
AP and BP, they are not a part of.
Uh,
Netra.
Yes, ma'am.
Yeah.
QA is equal to QA is equal to QC.
QA is equal to QC.
QA is equal to AC.
No. QA is of QAC. Now you have to say a side of QBC.
Sorry, ma'am. QA is equal to QC. QB.
No, say one answer. QA is equal to?
QC.
No, you're not sure about it. Srijana. Madhumita.
Ma'am, QA is equal to QB.
Okay. Okay.
And CQ is equal to CQ because it's common, ma'am.
Okay.
And AC is equal to BC.
How do you know AC is equal to BC?
Ma'am, P bisects the triangle. PQ bisects the triangle.
We are starting now. We are starting the proof now. We don't know. We have to prove that, AB is bisected. So, Sindhu? Who else is there?
Ma'am, no similarities, ma'am.
Krishmika Shri, Krishmika, Sindhu, Sanjay.
Ma'am, there is nothing same, ma'am.
Oh, one more information is there. There is one more information.
Angle QAC is equal to QBC.
Very good. Was that Netra?
Yes, ma'am.
How do you know that QAC is equal to QBC?
Ma'am, angles of opposite angles are equal.
Angles opposite to equal sides are equal. Correct. All of you agree with Netra?
Yes,
So
ma'am.
QAB, the triangle below QAB, QA is equal to QB is given. So this angle is equal to this angle. Angles opposite to equal sides are equal. So this angle is equal to this angle. Let's call it 1 and 2. Angle 1 is equal to angle 2. Now we know that this does not make any congruence rule because it's SSA. It's SSA. It's two sides and some other angle, which is not a valid congruence rule. So we don't have sufficient information to show that these two triangles are congruent. So what we do? We take up
Two different sets of triangle, ma'am.
Yeah, so we take up sorry. Sorry. So we take up the triangle like this, PAQB. So we take up this triangle and this triangle. We show that these two triangles are congruent. So Krishmika Shri, how do we prove that PAQ is congruent to PBQ?
Ma'am, AP is equal to BP, ma'am, that is given.
Okay,
AQ is equal to BQ, that is also given, ma'am.
very good.
PQ is equal to PQ, common side, ma'am.
Super, very good. So what rule the triangles are congruent?
Triple S, ma'am.
SS is congruence criterion. The two triangles are congruent. So CPCTC, what will you write? I'll mark
Angle.
some angles. I'll mark some angles. You tell me which you will write. Yeah.
Angle 1 is equal to angle 2, ma'am.
Because we have taken these two triangles, we are going to show that these two triangles are congruent. For that, which one will be suitable? Yes, Raja, which will be suitable?
Angle 5 and angle 6.
Yeah, so we should say CPCTC, angle 5 is equal to angle 6. Angle 5 is equal to angle 6 CPCT. Now we come to this proof. In triangle QAC and QBC, instead of 1 is equal to 2, we say 5. Now we proved that 5 is equal to 6. So angle 5 is equal to angle 6. Same information. We'll just write 5 is equal to 6 instead of 1 is equal to 2. So now this makes SAS. This makes SAS. You can see here. This is the included angle. These are the two sides. These are the two sides. This is the included angle. These are the two sides. So SAS rule the triangles are congruent. So now that the triangles are congruent, CPCTC, you will have AC is equal to BC. Because how will you name the triangle? QAC is congruent to QBC. QAC is congruent to QBC. So you get AC is equal to BC. AC is equal to BC, CPCTC. And then this angle is equal to this angle also CPCT, because see, your angle C is in the third position. You said QAC is congruent to QBC. You can see a CC. So C of this triangle is equal to C of this triangle. C of this triangle is equal to C of this triangle. So these two angles are equal. So if you mark them like whatever, don't get confused. Okay, let me say 7 and 8. So angle 7 is equal to angle 8, CPCT. But 7 plus 8 is equal to 180. But 7 is equal to 8. So you will get 7 is 90 degrees. When two angles are equal and their sum is 180, they're equal and their sum is 180. So each of them have to be 90 degrees. They're equal and their sum is 180. So each of them have to be 90 degrees. So we have done it both the ways. You need to, read the proof many times and understand, children. That's what it is. For some of us, I told, for some of us, proofs are very easy. We struggle with the numerical ones. But for most of us, numerical ones are easier than the proofs. Mostly, as far as I have seen, children find proofs a little difficult to remember. Like you need to practice a lot. Because when you learn many proofs, it's like, how do I know I have to start like this? So I've been telling you, every proof I've been telling you why we have to take up. Now see, in this case, I told you why we take up these two triangles, because we don't have sufficient information. So we take up these two triangles to show that 1 is equal to 2. And then you can use these two triangles and show that they are congruent. Earlier, we did not have this information, 1 is equal to 2. Shall we go to the next one?
Yes, ma'am. Yes, ma'am.
Okay. Don't think we have time to write this, children. I'll just explain this one. Before that, take a screenshot. Complete all this by the next class. Take a picture, children.
Taken, ma'am.
Yeah. This is exercise 7.3. The examples and exercise 7.3.
Taken, ma'am.
Yeah. 1 minute, 1 minute. What is this? This is the first one. Oh, it's a continuation, I think. Oh yeah, it's continued. Okay, so don't get confused. I've just put the question and this one here. It continues like this is the first slide. Okay, so here we have two proofs here, and it continues this one and this one. These two are the same pictures. What you see here. What you see here. So take a picture. 1 minute. Let me clear the slide. Yeah, take a picture of this one. This is answer 1. This is also answer 1. You don't have to write this again. When you're writing the second slide, you don't have to write these two. For me to explain, I have to have the figures, on the same slide. So I have put it. You don't have to write this again. This you don't have to write. In the first slide, you've already written it. So in the second slide, it's a continuation. You just have to write this one and this one.
Taken, ma'am.
All right. Second one.
Taken, ma'am.
Okay.
Taken, ma'am.
Taken, ma'am.
Yeah. There's a third one.
Taken, ma'am.
All right. Oh, that's all. Okay. I think 4, I already did it earlier, no? Yeah. Fourth one I had, and while doing exercise 7.2, I remember. The fourth one, I had already given the proof there. So that is the fourth one. All right, children, please complete these before the next class. Now, I think I just have time to explain now this one. Let me do that. So here P is a point equidistant from two lines L and M intersecting at point A. So P is a point, let me use this one. P is a point equidistant from two lines. L and M. The lines are called L and M. So L is a line, M is a line. These two are intersecting lines and they intersect at A. So let's draw that first. L is a line. M is a line. M is a line. L and M are two lines. They intersect at the point A. So this is A. They intersect at the point A. Now P is a point equidistant from both the lines. So we have to take a point P, which is equidistant from both the lines. So see somewhere here. Okay, there's a point P. It's equidistant from both the lines, meaning when you walk from P, equidistant always means see, whenever we say distance in mathematics, it's always the perpendicular distance. In mathematics, whenever we say distance, when we say in this context, when we say equidistant, P is a point equidistant from two lines L and M. In this context, it always means perpendicular distance. The perpendicular distance from P to the line L and M. So see here, the distance, the perpendicular distance from P, because the question is, see here, let me make it more clear. Now you're standing at P. You're standing at P. Now to reach L, you can walk like this. You can walk, see from P, if you have to reach the line L, okay, if it is some distance, from here you can touch L, you can walk like this, you can walk like this, you can walk like this. So which distance are they talking? So it's the perpendicular distance. From P, from P, if you have to touch the line L, you can take so many routes, no? So you can go like this, you can go like this, you can go like this and touch L. So which line are you talking about? So we are talking about the perpendicular distance. We are talking about the when you can take many routes, then it is the perpendicular route, the perpendicular distance. So P is equidistant from two lines L and M intersecting at the point A. So see here, perpendicular distance from P to L, perpendicular distance from P to M. So they've called this, the figure is given, they've called these points B and C. So PB is the perpendicular distance from P to L, line L, and PC is the perpendicular distance from P to the line M. And these two distances are equal. It's given, it's equidistant. P is equidistant. That means these two distances are equal. And they're perpendicular because there are many routes from P. If you want to touch the line L or M, there are so many routes. Which route? Perpendicular route. That's why we know that there's already 90 degrees. Show that the line AP means you should join A and P. You should join A and P. Show that the line AP bisects the angle between them. So this is the line AP. You must prove that, show that AP bisects the angle between them. So between them meaning which is the angle? See here, P is a point equidistant from the two lines L and M intersecting at A. Show that the line AP bisects the angle between them. So here you'll have to prove that this angle is equal to this angle. You'll have to prove that these two angles are equal. I'll draw the figure again, children. Two lines L and M. So this is line L and this is line M. They intersect at the point A. Okay, this is one thing. Now P is a point. P is some point which is equidistant from L and M. If you walk from P to L, if you walk from P to M, the distance is the same. And the distance is the perpendicular distance. So P, this is P. P to L, perpendicular distance. P to M, perpendicular distance. This distance is the same. Equidistant. P is equidistant. So these two distances are the same. And perpendicular distance, so 90 degrees. Now we need to show that AP bisects angle A. Bisects angle A. So we need to show that angle 1 is equal to angle 2. So see here, children, we have all the information in this triangle and this triangle. You can see this is 90 degrees, this is 90 degrees. 90 in the first triangle, 90 in the second triangle, right angle. And then AP is the common hypotenuse. See, opposite of the right angle is the hypotenuse. Opposite of the right angle is the hypotenuse. So AP is the common hypotenuse. So hypotenuse. And some other side. And some other side. So see here, this is B, this is C. So PB is equal to PC. PB is equal to PC. Some other side, no. So PC of one triangle is equal to PB of the other triangle. S. So by RHS congruence criterion, these two triangles are congruent. CPCTC, 1 is equal to angle 2. Is it fine, children?
Yes.
Yes.
All right, children. All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you, ma'am.
Thank you, children. Thank you. Thank you, children.
Thank you, ma'am.
Thank you.